1.13, removing discontinuities. What is a removable discontinuity? That's when the limit as x approaches c exists, but the limit as x approaches c does not equal f of c. So this is, if you recall from before, this is a hole, and f of c could be undefined, or f of c could be different from the limit. To find the x value of the hole, what you want to do is first factor this out. So x squared minus 1 is x plus 1 times x minus 1. And on the bottom is x minus 1. So you can see here that x minus 1 cancels out on the top and bottom. So when x is equal to 1 is where the hole is. How do we find the y value? So you see our function we have left is x plus 1. You just plug the x is equal to 1 into x plus 1. 1 plus 1 is equal to 2. So y is equal to 2 right here. So if you notice what we have left here, like this is f of x, right? And we canceled out the x minus 1 and x minus 1 on the top and bottom. We have x plus 1 left, which is just a line, right? However, at 1, the graph is undefined. Anytime you cancel out something on the top and bottom, the graph is what's left with just a hole. Because if you plug in x is equal to 1, right? It's 0 over 0. That's undefined. So you can't do that. Question 2. If the function f is continuous for all real numbers, and if f of x is equal to this, when x does not equal to -4, then f of -4 is equal to what? So they're just asking what's the value of the hole, so we can fill it in here. Because we want this to be continuous, they just tell us this function for all values not -4, so f of -4 should equal the limit here. So let's first factor this out here. X plus 4 times x plus 2 over x plus 4. And you see the x plus 4 in the top and bottom cancels out. So we just plug the -4 into here, into the x plus 2. It's going to be -4 plus 2 equals -2. So f of -4 should be -2 right here, just like this. So just to visualize the problem, f of x is this function for all x values not equal to -4. So like this point here would be -4 comma -2. They ask us to find f of -4 at this point, what it should be for the function to be continuous. So therefore, when f of -4 is equal to -2 right here, this becomes a continuous function that's smooth. You can draw it without ever lifting your pen. Last example right here before you get to do some practice. Let f be the function defined by this. For what value of a is f continuous at x is equal to 6? So it's very similar to question 2, just worded differently. In this class, you'll see a lot of questions that asks the same kind of concepts and skills, but it's in different contexts. So it's really important to do your best to grasp what the question's asking. First thing we can do is let's factor out the top. X minus 6 times x plus 3 over x minus 6. And you see here the x minus 6 cancels out on the top and bottom. So if you see right here, x plus 3 is equal to a. But we have an x value of 6, right? So 6 plus 3 is equal to a, and then 9 is just equal to a right there. So this is a similar concept to the previous question here. It's as if we had for x values not equal to 6, right? It might look something like this. And then we found our a value of 9, which fills this hole. Any questions, please ask your teacher. Thank you.